All right, now we're going to talk about transformations of polynomial graphs. A transformation can be a translation, moving it left or right. It can be a reflection, moving it across the X or Y axis. It can be a rotation, rotating 90 degrees, 180 degrees, whatever, around a point. It could also be a dilation where we make it larger or smaller. So we're going to be talking about all different types of those. The skill is to identify the effect on the graph by replacing f of x by f of x plus k, or k times f of x, or f of k times x and f of x plus k for specific values of k. Meaning, whatever we decide to put in here, they're going to be specific values, but when I look at each one of these, I know what's going to happen to those. Experiment with cases and illustrate an explanation of the effects on the graph using technology. So this says identify the transformation of this graph, this parent function of x cubed, that produced the graph of the given functions g of x. Then graph g of x on the same coordinate plane as the graph of f of x. So here's my f of x right here. I know this is it because it goes through 0, 0, 1, 1, negative 1, 1, 2, 8, negative 2, negative 8. So this is my y equals x cubed, or f of x is equal to x cubed. Then we're going to graph g of x here by applying the transformations to these reference points. So they've chosen these 3 points and they're saying this is what we're going to do to the function. And this kind of gives us a good sampling to see if you remember what transformations do. This means the same as applying f of x plus k. This is not attached to my x. This affects the entire function. So this is going to move my graph up or down. And in this case, this tells me that I'm going to move down 1. Whenever you have anything that is attached to the x, like right here, it is actually in the parentheses with the x, that means you are moving left or right. And because it's always x minus h is what's inside here, so you're always changing your sign. So if this is saying x minus 1, that means we are going to go right 1. I know a lot of times people will think, oh, x lies. It lies on this axis. It also lies to you when you're looking at this because it's saying, oh, x minus 1, yes, but x lies. So take it to the opposite side. That means we're moving it right 1. Now, what does that number in front of that graph do? So this is telling us what we've already said, a translation of 1 to the right and 1 down. This is a vertical stretch by a factor of 2. Okay, think of this. A vertical stretch means it's stretching it up. One way that I like to recognize these is that when there is a whole number and when it is a fraction. Think fat fraction. If there is ever a fraction in front of your function, then it's going to make it wider. What does that do? If this makes it narrower, skinnier, so we can say this, skinnier, more narrow, that's what this number in front of this does to your function. So that's making this, my parent function, it's making it a little narrower, making it a little skinnier. This is saying vertically stretching. It is vertically stretching it up towards this. Well, what if that were a fraction? and I said fat fraction, it means it's widening it, and it kind of compresses that down to the horizontal axis. So I want you to think about those terms because you'll see that. Is it a vertical stretch? Is it a horizontal compression? Is it a vertical compression? Is it a horizontal stretch? And you have to think, what does that really mean? So vertical stretch, getting skinnier because this is a whole number. Horizontal compression, if it were a fraction, it would be getting fatter. Well, let's see if there's anything we need to do. What they did here, they just took your points that you were given, which were 0, 0, 1, 1, and -1, -1, and then they applied this to this, because what did we say we did? I think we said we went down 1 and right 1. So you could really take that and do this with this point. What did we say? It went down 1 and right 1. So that point is that one. Down 1 and, what am I doing wrong here? Oh, we've got to stretch it. True. So that means we also have to multiply this by 2. It didn't affect this one because we had to multiply it by the 0. So you're going to plug this in, and then these are the points that you end up with. You can also just graph this in your calculator and you will get exactly what you need. Let's just look at this one and see what it says is happening. We've got this out here. We've got this happening in here. This is attached with the X, and then we have this number in front. So I know it's going to be shifting, translating up 4. What's happening here? It's a positive, so it's going to be going left 3. Now, what does this say? A horizontal compression by a factor of 1/2. Why are we saying that? Because we had to cube this, because this is what happened, and then we had to cube it. Let's look here to see what we need to put in.